What happens is that momentum was conserved. When I was holding the mass up here, stationary, there is no momentum. So when the mass comes down, the cart has to move in the opposite direction to the mass to make up for the changing momentum of the mass. Okay, so here's an example of a problem that we can solve with the law of conservation of momentum. So the question is, a 100 kilogram man is stuck at rest on an icy pond. He has a ball with him with a mass of 2.0 kilograms. He is 10 meters from the nearest edge of the pond. If he throws the ball with a speed of 5.0 meters per second away from the nearest edge, how long does it take him to reach the nearest edge? So to answer this one, we're going to need to use the law of conservation of momentum. So the initial momentum is equal to the final momentum. And here's the pond, here's the man holding the ball. Now to start with, the man and the ball are stationary. So the initial momentum is 0. The final momentum is equal to the mass of the man times the velocity of the man plus the mass of the ball times the velocity of the ball. And so he throws the ball and the ball travels this way and the man travels this way. Here's the nearest edge here. And so what we need to do is work out the velocity of the man, and we'll be able to use that velocity to work out how long it takes him to get to the edge. So we've got that the mass of the man times the velocity of the man is equal to minus the mass of the ball times the velocity of the ball. And so the velocity of the man is equal to minus the mass of the ball times the velocity of the ball over the mass of the man. So this is equal to 2.0 times the velocity of the ball, which is 5.0, over the mass of the man, which is 100. And we've got a negative, and so we end up with negative 10 over 100, or minus 0.10 meters per second. Now this negative indicates that they are in opposite directions. So as the ball goes away from the edge, the man is going to go towards the edge. So the velocity of the man is equal to 0.10 meters per second towards the nearest edge. And now he's starting from rest, so we can use that the distance travelled, x, is just equal to the speed times the time. So the velocity of the man times the time. And so the time it takes the man to reach the edge is equal to the distance he has to travel over his speed. And the distance he needs to travel is 10 meters. And the speed he's going at is 0.10 meters per second. And so this tells us that it will take him 100 seconds to reach this edge. So 100 seconds, or 1 minute and 40 seconds. So to do this, we needed to assume that this icy pond had no friction. If there was friction, then it would slow him down and he might not actually have enough energy to reach the edge.